So if this is the liquid or the water, we are told, so a stick placed within. So the stick is here. Let me use a different color. This is a stick within the water. And when it gets to the surface, a normal this appears bent. So it will bend at the boundary between. So it's just like a spot or coin placed in water. So an observer here watching this vertically from one side sees the stick to be bent. The angle of this appears to be an angle of 45. So if this is the first normal, just like the coin, it appears bent to the observer by this angle. So it's just like the coin placed here. Okay. So what will be the actual? Now, if I rule a vertical line from the tip, which is the actual, this is also the normal. What will be the actual inclination? What will be the actual inclination? So how do I get that? Let me extrapolate this refracted ray backward. Oh, let me change the color. So when I extrapolate this ray in the opposite direction, it will be here. Just as the theory we have done. This angle corresponds to the angle of refraction, 45 degrees. So it means that if I want to determine the angle, I must know this angle from the surface. So I must know this small angle and then this angle. Or if I'm measuring it from the normal, if I'm measuring the angle from the normal, it must be this angle here. This will give me the actual inclination because the angles are measured from the normal. So N1, N2. So if I'm measuring it from here, it must be this angle. Now, when I have the refractive index of water 1.33, when I apply Snell's law, I have refractive index equal to sine of 45 on sine of I. I will be this angle. So let's use arrows. They are rays picked by an observer. So I is here. So if I'm moving from air to water, this will be it. If I'm moving from water to air, then it must be 1 over reverse. 1 over the refractive index equal to sine of I over sine of 45. So in this case, I is the incident and R45 is the refraction. So both ways, you can look at it from air to water or water to air. Gideon, your hand wanted to be up.
Yes, sir.
Have I
Please,
you?
please, not really, but when you are taking the Snell's law from water to air, say, is it not supposed to be rather the sine I
No,
over sine 45?
if water to air, it must be sine I over, and so that's what I've done, reverse of this. Okay, so this is air to water, and the second one is water to air. But it must be the inverse of it. Whichever way you look at it, you must get the same results. So 1.33 is equal to sine of 45, which is root 2 on 2. Root 2 is 1.414 over 2 is 0.7071 over sine I. Let's, General Saki.
Get why it's sine 45 over I.
Pardon?
This I don't get why it's sine 45 over I.
Oh, absolute. If I'm looking at Snell's law, don't forget Snell's law is sine of the angle of incidence over sine of the angle of refraction. When we are moving from air to a dense medium. So when I'm moving from air to water, the angle of incidence is 45 and I will be the angle of refraction. Because I'm moving from air to water. So it's like changing the direction of the ray to be this. Saki, are you okay?
Then please take it again.
Snell's law is saying that absolute refractive index, and don't forget for absolute refractive index, the first medium or the light must actually come from air. So Snell is saying that absolute refractive index is sine I over sine of R, where I is the angle of incidence, R is the refraction. So if I intend moving in this direction, then the angle of incidence will be 45, and then the angle of refraction will be I. So that's what I've used here. But I can also pick it from moving from water to air, and this will be the reverse, which is this. Saki, are you okay?
Yes, sir.
Both ways must give you the same result, so you can confirm. All right, so help me find I. Please help me calculate the value of I. Saki. Saki.
Yeah.
Your hand, okay, Asima.
Sir, Mr.
Okay.
It doesn't mean the 45 is angle of refraction.
So if you are moving from air to water, the angle of refraction, which is 45, becomes the angle of incidence. But from the actual question, Please, let's use this. Let's use this one. Though it's the same, but to help you understand, let's look at the refractive index from water to air. So in this case, I will be the angle of incidence. So sine of I over the angle of refraction, which the question gave us as 45 degrees. Okay, and we learned that absolute refractive index 1 to 2, or air to water, times the refractive index from water to air, this product is equal to 1. So if from air to water we are given 1.33, then the refractive index from water to air would give us 1 over 1.33. Please, are we okay? Ashma, are you okay?
Yes.
Therefore, making the refractive index from water to air the subject from this one, we'll have 1 divided by 1.33, which is equal to what? Please help me do this. Help me find this. 0.7518.
19, sorry.
Okay. 0.7519. So when we substitute it here, we are moving from water to air. We have 0.7519 giving us or equal to sine I over sine of 45. Sine 45 is root 2 on 2, which is 0.7071. So when we make sine I the subject, we have 0.7519 times 0.7071. And give me this, multiply this for me. 1 times that product. (0.7519) times 0.7071. Oh, who is doing that? Michelle and Co. Anita.
0.5317.
0.7.
5.
Your what is the name? Yasmin, your line is breaking. 0.
That's 0.5317.
Help me find I. Help me find the value of I.
32.12.
Exactly. So approximately 32. But what I'm saying is that instead of looking at it this way, you can also pick it from refractive index from air to water, which in this case, the angle of refraction, we are moving in this direction. Before, it was this direction. So you can also pick it from sine of 45 over sine of I, so that the absolute refractive index, which we are given as 1.33, will be equated to sine of 45 on sine I. And I, the value of I will be the same as what we got. So you can also look at it from. So it means that this angle here is 32. Class, if this is 32, what will be this angle? What will be this angle? If this is 32, what will be this angle? Then you use that to calculate for this small angle for me. What's this angle? 1 what? 150.
135.
Did you say 125?
135.
So 135. What will be the small angle then? That's 13. Good. So
13.
thank you. This is 13. So if an observer is here and you want to look at the actual inclination of the you have to go through this angle. And so it will be 45 plus the small angle 13, giving you 58 degrees. So the actual inclination will be 58 degrees. Don't forget what is given to you as 45 is the apparent inclination where the image appears to be. But if you are looking for the actual, it should be okay from the surface to the actual where the stick does not bend. So 45 plus 13, which is 58. That is the problem of the day. It's a very nice question because most times we only use apparent real dead thing, but to give us this is an addition. Saki.
So I'm confused as to how we got a 13 and a 35.
And then Gideon. Let me hear from Gideon too.
Answer please. It's okay.
Okay, so please, for understanding of all, let's look at it again, okay? Let me use the same diagram for, and then clean. So the question actually says that the apparent inclination, okay, apparent means virtual thing. So when an observer looks from the top, he sees the apparent inclination of the stick to occur at the angle 45. Then he asking the real inclination. Don't forget, the real inclination will be the angle from the surface to the real object, not its apparent. Okay, so this angle from the normal would give us the actual or the real inclination. All right, we know from corresponding angle point of view. That is why I said to answer this question very well, you must draw. If you don't draw it, you may not. And I saw some of you also drawing without without any bending of the stick when it is viewed from above. And I was we've gone through this theory, so the stick was just straight from below the water surface to the outside. So if this is the stick, and when it gets to the water surface, it gets bent, then this is the angle of incidence. Okay, this is the refraction. Once we are given the refractive index, as I said earlier, we can pick refractive index from both ways, whether air to water or water to air, and it will be the same thing. If we want to follow this direction, water to air, then the refractive index from water to air is equal to the sine of the angle of incidence, sine I, over sine of the angle of refraction. Don't forget the refractive index from water to air is the same as 1 over the refractive index from air to water. So this is sine of I on sine 45 degree. We were given the absolute refractive index 1 over 1.33 is equal to sine of I on sine of 45. So here we find I. Sine I giving us sine of 45 over root 2. Sine 45 is root 2 on 2. So if you divide root 2 by 2, it will give you 0.7071. This divided by 1.33. I therefore is equal to the sine inverse of this ratio. And this gave us 32 degree. Are we okay here? Saki, are you okay here?
Yes, please.
So if I, which is this, is 32 degree, this is 45. By corresponding angle rule, this is also 45. And we saw that from the theory, that if this is R, this will also be R. Because this is the extension of this ray, this refracted ray coming out through air. Okay. Now, it means that what the actual inclination is an angle from the surface of the water or the normal to where the ray does not bend at the stick. And this is it. So it means that to determine this angle, I have this side of the angle, 45. I must know this small angle as well. How do I get this? Once I have this to be 45, I can easily calculate for this by subtracting 45 from 180, and that gave us 135. So if this is 135, add sum of angles in a triangle is equal to 180. So add this and this and subtract that from 180. Saki, are you fine?
Yes, sir.
Good. So that gave us 13. So if this is 13, then the actual angle of inclination from the surface to the stick where it doesn't actually get bent will be 45 plus 13, which is 58 degrees. So that's the actual inclination of the stick. So please, when you get such questions, you can analyze it better when you put the whole information into a kind of drawing. Frank, are you fine? Oh, Frank is not here. Okay, class, give me a minute to drop attendance. Okay, let me drop attendance, okay? Hello, Frank.
Please, would it be easier to use the Snell's law, the second one, where n2 sine theta is equal to like n1 sine theta? So you get like 1 sine 45 is equal to 1.33 sine theta. Then you make theta the subject, then you get the 32 degrees.
Frank, come again.
Sir, please, I said that wouldn't it be easier to use the other Snell's law that says that n2 sine theta is equal to n1 sine theta, where you get 1 sine 45 to be equal to 1.33 sine theta. Then you make theta the subject and you get the 32 degrees.
Oh, you can also use that. You can also use that. Okay. All right. Anita, are you okay?
Yes, sir.
Those of you who couldn't solve this. Then about the second question. The second question, I was a bit surprised. A lot of you were not attentive because look at the question where you are given angle of incidence and angle of deviation. Where is it? I'm coming. Let me. Good. I've reposted the second question on the page. So here we have a table of angle of incidence, angle of emergence, and angle of deviation. So I, E, and then deviation. In fact, about 90% of you got this correct. 90% of you. So slash degree. Then angle of incidence, we have 30, 40, 50 up to 70. Angle of emergence, 45, 40, 35, 30, and 28. Angle of deviation, we have 35, 30, 32, 37, and 45. So these are what goes into the table of value. Then from the table of values, discuss the relationship between the angle of incidence and the angle of deviation. So from the table of value, you are asked to discuss that relationship between I and E. And the relationship is that as I increases, so the angle of deviation rather, as I increases, sigma, which is the angle of deviation, also decreases to a certain least value and then increases from there. So it decreased 35, decreased to 30, then from 30, as this increases, instead of us to see a continuous decrease, it rather increases from this point, 30 to 32, 37, 45. And from the theory, that is what we saw, that in refraction of light in triangular prism, as you increase the angle of incidence, the angle of deviation also decreases, reaches a certain minimum value, and begins to increase. Okay, so we discussed that in our theory. Then the second question, determine the minimum deviation and justify why this is the minimum deviation. Determine the minimum, the least deviation or the least angle of deviation. When you look at these values, this is the least. This is the least. 30 is the least, meaning that minimum deviation is 30 degrees. And justify why this is the minimum deviation. The justification is that from the theory, we said that when we get to the minimum deviation, angle of incidence must be equal to the angle of emergence. So when you look at the table, at this value, I is 40, E is also 40. So it satisfies this condition. Class, are we okay? So the justification is that at this angle we are calling as a minimum deviation, it is a minimum deviation because at this point the angle of incidence is equal to the angle of emergence. That is why this is the minimum deviation. Then the third question, using the information above, deduce the refractive index, the refracting angle of the triangular prism. So here we use theory. From our theory, we saw that where the ray or light passes through the prism symmetrically, or when ray passes through prism symmetrically, and note that whenever the ray passes through the prism symmetrically, it means we are at the minimum deviation, the least deviation. Minimum deviation I as sigma m or dm, whichever way you will call it, will be equal to 2 times the angle of incidence minus A. And this is from total deviation formula, which is equal to I plus E minus A. And at the minimum deviation, when I is equal to E, we'll have I plus I or E plus E. And so this is what we'll have. So we can use this to calculate for the refracting angle of the prism. So the minimum deviation is 30. which is equal to 2 times what the angle of incidence at this value of minimum deviation, which is 40, minus A, and A is equal to 80. 2 times 40 is 80 minus 30. We have an angle of 50 degrees. This is the minimum deviation. This is the angle, refraction angle of the prism. And a lot of you got this correct. Then, calculate the refractive index of the material. The refractive index of the material. You can refractive index of the material is sine of angle of incidence over sine of R. But we are at the minimum deviation, and at the minimum deviation, when you make I the subject from this equation, you have refraction angle plus the minimum deviation all divided by root of 2, all divided by sine of, at the minimum deviation, A is also equal to 2R, and R is equal to A over 2. So come and substitute A over 2 here. You are good to go. So you have sine, you have calculated for A, which is 50. The minimum deviation is 30. Divided by sine of A, which is 50, divided by 2, so sine 25. The rest is just calculation. So the numerator will be sine of 40 on sine of 25. At this point, please, nobody should rush to cancel sine, because sine is not multiplying, it isn't order. Sine is not multiplying 40. Sine 40 is an identity. So don't be tempted to cancel sine. So input sine 40 divided by sine 25. And this must give you 1.52 to be the refractive index of the first place. Please, is there any question? Is there any question here? No question. All right. The next question is the graph. Plot a graph of minimum deviation on the vertical against, did I say minimum deviation? No. Plot a graph of deviation on the vertical against angle of incidence on the horizontal. So I must have, let me use straight line. My vertical, my horizontal. This must be deviation slash degree. This is I, also slash degree. Let me divide this into 6. So 6, 6. And I'm doing this to explain something. Good. Count if it's up to, the vertical is up to 12 for me. Then the numerator, the horizontal axis, I'll also divide it into 10. So 5, this is 2, 1, 2, 3, 4, 5. Good. Now, assuming I want to go by 5 every 2 centimeter to 5 units. Okay, 5 times 12 is 60. Okay, if I'm going every 2 centimeter by 5, 5 times 12 is 60. My maximum sigma value, deviation value is 45. So I can pick it this way: 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 65, 55, 60. Good. And if I want to, looking at my values, my minimum I value is 30, maximum I value is 70. Okay, so if I pick 5 out 5, I have 10. 5, 10, 5, 10, I'll have 50. I cannot, please, I want to take you to how to pick scales. So if my minimum I value is 30 and maximum I value is 70, it means that if I take 5, 5, 5, 5, I'll end at 50. I'll not be able to get my maximum value, 70. Class, are you there? Are you with me?
Yes, sir.
Good. So I cannot take horizontally, I cannot take 5, 5. I can take 10, 10. So that I'll have a total of 100. 100, I can get 70. So 10, 20, 30, 40, 50, 50, 60, 70, 80, 90, and then 100. I'm good to go. Now note that in choosing scales, we do not accept some values. When you pick scales and your values are like fall within these numbers: 3, 7, 9. Of course, if 3 will not be good, 6 will not be good, and 9 either. So 3, 7, 11, 13, 17. These scales, WAEC do not accept them. So note them. The moment you choose scales and they are like this, it will be cancelled. WAEC do not accept this value of scales. Okay, These and they are multiple. These values and they are multiple. So 3, 6, 9, 12, no. 7, 14, no. So note them. Then when you plot, let's plot our information. Vertically, we have 35. The first value to plot is 35. 35 goes with I value of 30. So let me use straight. So 35 horizontally. Going with I value of 30. Once they are intersecting here, I indicate my point here. Then 30 is going with 40. 30, 40. I'm just, oh, what has happened to my vertical line? Good. 30 is going with 40. And so this is the point of 10. Then the next point, 32 is going with 32 is going with 50. Let's assume 32 is here. $50 is also here. Then 37 against 60. $37 is somewhere here. Then 45 going with 70. Good. Now, you see, some of you had a curve. Some of you had a straight line. How do you decide that this will be a straight line or a curve? The theory said that a graph of minimum deviation against angle of incidence is a curve. So the theory said that graph of this deviation against angle of incidence is a curve. And so you must understand the theory and then realize that this is a curve, not a straight line. Do not find the line of best fits. It's a curve. Okay. So we are drawing a curve because we understand the theory. Now, You see, please, is there any question here? If you have any question concerning what we've done, you can quickly ask. I want to clear the gray lines. Good. Then, you see, in graph, we always want your graph area to cover about 2/3 of the page. Meaning, when we divide this whole graph area into 3, it must cover at least 2. When you divide it into 3, it must cover 2. When you divide it into 4, it must cover 3. Unless the situation is such that it cannot be possible. And it cannot be possible in situations where you are asked to start from the origin. If you are plotting a graph and you are told to start from the origin, then it means you must, your axis must start from the origin 0, 5. It must be a continuous interval. Okay, just as we have done. Okay, so if plot a graph of this against the starting both axes from the origin, then it means you cannot break the graph. Your axis, each axis must be continuous with that equal intervals. That's what I mean. So here we have 0, 5, 5, 10, 10, 15, 15, 20. We have equal intervals of 5, 5, 5. Then when you come to horizontal, 0, 10, 10, 20, 20, 30, we all equally have equal intervals of 0, 0, 0, meaning both axes start from the origin. Class, are you okay? Are we okay?
Yes, sir.
If your graph, your question is not restricting you to starting from the origin, then you have that liberty to break the graph. And what do I mean by breaking the graph? You see, vertically, when we look at the deviation, angles of deviation, the least is 30, meaning that we are not plotting anything from 0 up to 25 or even 29. So if the question does not require me that I must start from the origin, I can decide to break the vertical axis. How do I break the vertical axis? Instead of starting from 0, 0, no, I'll just indicate that this, though I'm starting 25, 25 intervals, this can be 25, the next is 30, meaning 4 centimeters, 35, 40, 45, then 50. What is the maximum value of deviation? What is the maximum value of deviation from the table of value?
50.
Hey, are you 50? Good. So 25, 30, meaning I'm making it 4 centimeter. Okay. 25, 30, 35, 40 must be here. Gideon, I'm coming. 40 must be here. Then,
Sir, please, the maximum angle of deviation is 45 degrees.
yes. So 45 and then 50. 50 is here. And I'm breaking this axis so that my graph will cover a wider area. I can also do same to the vertical, the horizontal axis. The maximum is 70, meaning I will not plot anything until I get to 30. And here I can maintain this. Here I can decide to maintain this. If I maintain the horizontal one, all that I need to show is this. Project this. The axis indicate 0 here. Here is broken, so it's not continuous. It means I've broken the vertical axis, but the horizontal axis is still intact. Are we okay?
So please come again.
So I've extended the vertical, the horizontal axis, both horizontal and vertical, and I'm indicating 0 here. What it means is that horizontally it starts from 0, but vertically I've broken it, so it doesn't start from 0. Okay, so I've broken the vertical axis, and then the horizontal axis is still intact. Let's this time plot. Let's plot this time around. Gideon, what's your question?
So this my question was, so when you are writing the scale, are you going to write 4 centimeters
So
peak?
I'm coming.
Because when I say
We'll write it. So let's plot our values. When deviation is 45, and when deviation is 35, angle of incidence is 30. Then when deviation is 30, angle of incidence is 40. When deviation is 32, angle of incidence, so if this is 4 centimeters, then half of it will be 32.5. Okay, so 32 will be somewhere here. Let's pick the same thing. Angle of incidence 50. When deviation is 37, angle of incidence is 60. So 37 will be somewhere here. Angle of incidence 60. When deviation is 45, angle of incidence 70. So that when we plot, now, you see, when we broke the axis, our graph now is so much is enlarged. So we basically do this to enlarge the graph, but you can only break the axis on condition. And what are the conditions? One, if the question does not ask you to start from the origin, if the question doesn't ask that start both axes from the origin, you are free to break the axis. Two, if there's no question on intercept, even in curves, there's no intercept, but in straight lines, where you pick the line of best fit, there is always a question on intercept. So you can only break the graph if you are not restricted to starting both axes from the origin. And if there is no question which demands that find an intercept, you can also decide to break the axis. And the reason why we break the axis is so that our graph will cover a wider area. Because you see, when I looked at the graphs you plotted, some of you had a situation where your curve was hanging above here. Based on the scales you chose, it was hanging above here. The question is, what will you do to all this space below? No, it's not a good graph. In some other cases, the axis is chosen so that the graph will be here. All this space will be empty. No, we want your graph to always cover about 2/3 or 3/4 of the graph area. And that is why we decide to either break the axis if the condition prevails. Please, is there any question?
So this
If
come
you
again
don't,
on the condition.
your condition is that if your graph instruction demands that plot a graph of this against it, okay, and you are asked to start both axes from the origin, start both axes from the origin, it means you cannot break the graph. You must actually start from 0 and make sure that your intervals are equal, just as I have done. Just as I took you through earlier. Please, class, are we okay? Anita, Michelle, Janelle, Augustine, and the rest of you. So one, if you are to start from the origin, you cannot break it. Two, if there is a question on the intercept on one of the axes, you cannot break that axis. If you have to find an intercept, especially straight lines, you see, this is what I mean by intercept. I plotted a graph, and my graph area, my graph is like this. If the graph is like this, and there is a question on intercept, then it means that I must extend my graph to cut the vertical axis. I must extend my graph to cut the vertical axis. Okay, so the intercept is the point where the graph intercepts with this vertical axis. And here I mean intercept on the vertical axis. So I read where the graph cuts this and record. If there is a question on intercept, I cannot break this vertical axis. That's what I'm saying.
So please, it means that if there's a question on slope, it means that indirectly there's intercept involved.
So if there is a question on intercept, it means you cannot break this vertical axis, or if there's a question on intercept on the horizontal axis, you cannot break, and here this on the horizontal axis, your graph will be a negative slope like this. And if there is a need for you to determine an intercept on the horizontal axis, then it means you read where this graph cuts the horizontal axis like this. So these are situations where you cannot break the axis. It must be continuous. Or when you are asked to start from the origin. Start from the origin. Yasmin, are you there? You are not asking questions. Gideon, go ahead.
Simply, so if slope is involved, it means indirectly the intercept is also involved.
No. These are different situations. There can be a question on slope. There can also be a question on intercept. It is not automatic that whenever you are to find a slope, it means you are also to find the intercept. The question would clearly state that. Are you okay? Okay, Angie.
Okay, sir.
Sir, please, I wanted to ask that, like, I just joined, so I don't really understand what you mean by break the graph.
Hey, Angie. To break the graph, you see, means that look at the horizontal axis. It starts from 0, 10, 20, 30. So we have a continuous order of intervals throughout. So horizontally, I have not broken the axis. I have not broken the axis horizontally. Now, look at vertically. Vertically, instead of me starting from 0, supposing this is 0, and looking at my values, it means every 4 centimeter is 5 degrees. But I jumped from 0 to 25. Meanwhile, once the intervals every 4 centimeter is to 5, it must be 5, 10, 15, 20 before 25. But I jumped from 0 to 25. This is what I mean by breaking the axis. Okay? And we do that when you want to widen your graph, because graph must be larger enough for analysis. So if there is the need to break the graph so that your graph would cover a wider area, you must do that. That is what I mean by breaking the graph or axis. Now let's write the scale. The scale, as I told you, very, very important. How did I plot this graph? You must take the vertical scale and then the horizontal. Here I picked 4 centimeters. So 4 centimeter, two of the boxes. So 4 centimeter to the intervals 5, 5. So to 5, this has a unit, degree, not 5 units, 5 degree on the, not the y-axis. This axis has a name, deviation axis. It's not y. Why? Because the math, when it comes to graphing, they are always using x and y, but the physics has a name. Okay, we are saying that let the vertical axis be angle of deviation and let the horizontal axis be angle of incidence. So what did I write 45? So 4 centimeter to 5 degree on the deviation axis, and here it is 2 centimeter to 10 degree on the I/its unit axis, on the angle of incidence axis, this is the scale. Okay, not 4 centimeters to 5 units. No, if you write 5 units, then it means this vertical quantity has no unit. If you write 2 centimeters to 10 units, then it means this angle of incidence has no unit. That is why you are writing unit. Class, are we fine?
Yes, sir.
Good. Then you were asked to find the minimum value. The minimum value is this, the least angle of deviation. So using your graph, you plot this angle of incidence, which is giving us this, and trace it to. So this would give us the minimum deviation. So from the graph, minimum deviation is this, then you write it. Please, is there any question? Graph works very, very interesting. You can score everything if you adhere to the rules and all that. Okay. All right. The next area I want us to begin with from Thursday will be on Yasmin.
Please, can you go to the previous slide?
Yes, I'm here. Is that okay? Are you writing? Okay, then hurry up. I'll give you reading assignment on lenses. Once we've done mirrors, spherical mirrors, you can easily understand lenses.
Please,
Yasmin, okay. So note your reading assignment. You read on lenses. Okay, what lenses are, their functions, I'll put you into groups and then you will present this. So what are lenses? Their functions, then types of lenses. The types of lenses, their shapes, and what we use each one for. Types of lenses and functions of each. I'm giving you this so that next Thursday we'll begin with temperature and heat. So read on lenses, functions, and then specific types of lenses. Then Then we'll look at formation of images in lenses. This I'll discuss with you because we've done mirrors, spherical mirrors. This will be easier. Formation of images in lenses, both the types. Then the lens formula. The lens formula. So please read on this. I'll put you into groups by tomorrow for presentation. When you present, I'll probe. So you answer, the group members would answer. Okay. Please, class, are you okay? So note it. Lenses, functions, types, and the specific functions of the types. Formation of images in lenses, and then the lens formula. Okay. So let's begin with heat and measurements of heat. Then we look at temperature. Can somebody help me define heat? What is heat? What is heat? Anybody? We heat ourselves up in our homes. So, Morris, what is heat? Morris,
I'm trying.
try.
Okay. Is heat is the rise in temperature of a particular object.
Heat is the rise in temperature of a particular object. Morris has tried. Angie, what is heat?
Sir, please. Heat is a form of energy that can be transferred from one point to another due to temperature differences.
Okay. Heat is a form of energy that can be transferred from one
Point to another.
due to temperature differences. Okay, I saw another hand up. Ernest, you
Sir, please, the both of them have said it. I would have said heat is a form of it's a form of thermal energy.
Okay. It is a form of thermal energy. Okay. All right. So I think all contributions not so bad. The only thing is that some of them not so on point compared to others. So heat is a form of energy that can be transferred from one point or one body to another body due to temperature difference. Okay. So it's a form of energy that can be transferred from one point to another point due to temperature difference. So basically, it's a form of energy, heat energy. But Angie, let me probe what you said. You said it can be transferred from one point to another point due to temperature difference. So if 2 points have equal temperatures, what then will happen? Point A or body A and body B, okay, have the same temperature. What happens, Angie? Okay, somebody else is. Angie, hold on. Let me pick Gideon's view. Gideon.
So you can say there's equivalent.
Angie is saying that we can only transfer the energy heat when 2 points have difference in temperature. When you have the same temperature, what happens? Gideon.
There's equivalent temperature.
Equilibrium temperature, I don't understand. No.
So, okay, it was just something that I tried to guess. Yeah.
Okay. Okay. Let me pick the views of others. Okay, Frank, before Angie, let Frank come in.
Please, there is no transfer of heat between the 2 points.
There wouldn't be transfer of heat between the 2 points. Even though, so you mean that even though there will be heat, but it cannot be transferred. Is that what you are saying?
Yes.
Hey, there is heat we can't transfer because the 2 points have the same temperature. Okay, Angie.
But I only remember that if they have the same temperature, it means that they are in thermal equilibrium. So that means the temperature difference between them is 0. So then they'll not be transferred from that point to another. Maybe they'll be transferred to other points, but not.
Okay, thank you. You are right. You are right. So heat energy can only be transferred when there is temperature difference. So when two bodies have the same temperature, we have what we call thermal equilibrium. Okay, thermal equilibrium. Frank.
So does that mean that there is no heat between them?
There will be heat, but it cannot be transferred. It cannot be transferred to the other body. Okay. Oh.
That was perfect to me.
Nimako, mute yourself. So, example, you see, in our homes, whenever you put hot, when you have frozen water in a fridge or food items, okay, that are frozen, and you even open the door of the fridge. Do you know the frozen item begins to melt or will begin to melt? That is why there is a saying that if you are fond of opening the door of the fridge, your light bill will go up. Have you heard that before?
Yes, please.
That you are told if you
Yes,
regularly open the fridge, your light bill will go up. The light bill will go up because of this. The explanation to this is that, you see, when you open the fridge or when the fridge is closed, it means the items within the fridge are in thermal equilibrium. Putting items in the fridge, the idea behind it is that you want to extract the heat in the item. Okay, so as the heat in the items in the fridge is extracted, they will come to a point where they will all be at the same temperature. Okay, so the fridge actually extracts the heat out of items placed within. And this is the reason why when you move behind the fridge, the temperature there is so warm. The air which is blown at the back of the fridge is so warm. Okay, what you feel is the heat extracted from items within the fridge. So when this is extracted, it will come to a point where the items within will be at the same temperature, thermal equilibrium. And we use electric current to extract the heat out of the items in order to obtain this thermal equilibrium. So when you are fond of opening the fridge, it means that the atmospheric temperature, which is higher than the temperature within the fridge. So once we have this temperature difference, heat will travel from the atmosphere or the surrounding into the fridge. So once heat is transferred, the fridge must use electrical energy to extract it in order to cool. So it is like my work is done. I've managed to cool off items within. Meanwhile, you open the fridge to allow heat to come from outside. And so I must do work again. And what do I use to do this work? I must use electrical energy. So you open, I get energy, I must extract. And so your bill will go up. Frank.
Sir, so when you open the fridge, does the heat come inside or the cold air goes out?
The heat, you see, we are talking about heat. That the surrounding temperature is higher than the temperature within the fridge. So heat energy, which is clearly due to the sun, okay, will travel from the surrounding or the environment into the fridge. Is that okay? Heat will travel from the surrounding into the fridge to begin to, once the items absorb the heat, they will begin to melt. And you must take electrical energy to extract the heat once more. So this is how come your bill would go up. Then the air condition, the function of the air condition is also similar to this. Air condition does not blow cold air into the room, no. But the air condition is such that it must extract the heat energy, okay, within that space, throw it outside. And as the air condition does this, it will cool. The heat in the room is extracted and is blown outside by the fan. And so it will eventually cool off the room because the heat is extracted. You see, in using air conditioning, you are advised to always close your windows once you put the air conditioning on. If you are in a car and the AC is on, you must roll up the glasses. True or false?
True.
Yes, the reason is similar to this opening of fridge. My function is to extract the air within the space. The more as I extract the air within the space, okay, the better the room will be cooled. So if you don't block external air, external hot air from coming in, okay, my work will be in vain. Meaning as I extract, another one comes in and there's no way I can cool it to that constant temperature. And that's the reason why when you on the AC, you must roll up your glasses so that heat energy will not flow from outside. You know, air or heat, the air comes with heat, okay, will not flow from outside to affect the work that the air conditioning does. That is all. So that's the principle behind the Frank.
So the AC also takes out carbon dioxide like outside the house. So how does oxygen also get inside the house?
Frank, I've not said carbon dioxide though. The AC is extracting heat energy within a particular space. And the space is either your room or the interior part of your car. That is why you see most spaces where there are ACs, we have this glass windows so that we can easily seal, okay, to block external air from coming in because we want to cool off this space.
So doesn't that external air contain oxygen?
The external air, yes, it contains oxygen.
So if the AC is sucking out like the heat from inside containing air, how does oxygen also get inside?
No, we have air within the room. Okay, we have air within the room already, but the air has a higher temperature. Okay, the air within the room isn't carbon dioxide, even though it will certainly consist of certain carbon dioxide because of breathing and all that. Okay, but there is oxygen within the room, and we want to cool it off. So in extracting the heat, it does not mean it is preventing. Yes, we are more or less blocking flow of air within the space. Okay, but doesn't mean there is no air in the room. Frank, have I answered you? All right. Please, is there any question? So we'll look at heat. It's an interesting area to look at. Okay. Let me see if you have. All right. All right. So we'll look at it next week. Look at heat, look at temperature, and then the calculations in there. It's a very interesting area to look at. Okay. So class, this is where we end today's session. We'll continue on Thursday. But please do not forget your reading assignment. Lenses, okay, and what they are functions, types, and functions of the specific types, formation of images. Make notes because you'll be, as I said, you'll be presenting it, and then I'll be probing whatever you give me. So get the notes so that when a question is answered, you can be able to answer it as expected. If there is no question, then this is where I end today's session. Joshua.
Sir, please, the reading assignment under the lenses, will you send the slides in the group? In the group, or
is it the question, the areas to look at?
Like the assignment. Oh, we should go and make out.
Yeah, just make your research on the areas I've indicated. And let me get the groups. And when you get the group, you can contact yourselves and then quickly, you can also forward your whatever you're able to get as you are saying. Is that okay?
Okay.
So I'll get you the group by this evening, and then you contact yourself to begin working. All right. Okay, so let's end today's session here. I'll see you next Thursday. May the good Lord be with you, guide you, protect you in all your endeavors. Bye-bye.
Bye.